everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In this class, we will study about full wave rectifier. In our earlier classes, we already discussed half wave rectification process. In half wave rectifier, we will get output only at one cycle, which is 0 to pi, and for pi to 2 pi, the output is 0. So the output power of half wave rectifier is less. If I talk about the ripple factor is more in half wave rectifier. Due to this, the efficiency of half wave rectifier is less. So, to overcome these disadvantages, we will have full wave rectification process in which we will get output from 0 to 2 pi in both time periods, 0 to pi as well as pi to 2 pi. So, half wave rectifier is little less efficient than full wave rectification. Now, full wave rectifier have two kinds. One are center tape and second one is bridge rectifier. In this class, wave rectifier. In this, what we are seeing that one diode is connected in the upper part of the coil and the second one is connected lower part of the secondary coil. And we can see that here secondary coil is divided in two parts with this center tape mechanism. Now, what is happening? We know that alternating current or AC is coming directly to the primary coil of the transformer and secondary coil is receiving those voltages. Now, we know that output depends on the number of coils inside the transformer. So, we are using a step down transformer here. Why so? Because at input we are getting high voltage peaks and for diode circuitry we need little mud voltage. As an example, I can say that the coil ratio in this is 10:1. If I am giving 10 volt to the input, it is becoming 1 volt at the output of the secondary coil. Let's say in India we have 22 volts of AC signal. So this will become 220 volt of AC signal. Now it will become 22 volt at the secondary. Why so? Because this is the process of step down transformer. Now for the diode circuitry we will get the less voltage. Now here what we can see, if we consider this positive half, then the structure over here is plus or minus. The upper part of the coil is in this polarity and it is making this diode working in forward bias. But in lower part, what is happening? In lower part also we are giving the same value and it is also in this. So what is happening here? Negative connected to positive of the diode, it means this diode is working in reverse bias whereas this diode is working in forward bias in the first half of the cycle. So we are getting the output here which is nothing but the Vmax, which is the voltage over the secondary, we are getting it here. Now what is happening in the second half or this? In negative half, we are considering this one as the input for diode D2. Now, what is happening in the negative half? In negative half, the polarity will be negative and positive and similarly negative and positive. So, in this case, this diode D1 is working in reverse bias now. Why so? Because this is the positive of the diode which is connected to the negative of the secondary. Now, here diode working in forward bias. Why so? Because the positive of the coil is connected to the positive of the diode. Now in this second half or this negative cycle, we will also get the output which is nothing but Vs max, which is the voltage of secondary here. So at both 0 to pi and pi to 2 pi, we are receiving the output and similarly this is the adjoint of these two. So this is the working of what a full wave rectifier circuit is doing in the condition which is considered as center tape. Now we will discuss few formulas over it. Let us discuss first the peak inverse voltage PIV. The PIV is nothing but the maximum voltage which is across the secondary of the coil. So this is Vs max. Now here we can see that we have two voltages. So PIV of full wave rectifier is 2 Vs max. Clear? Why so? Because we are considering here 0 to pi and pi to 2 pi. Now the peak inverse current. What is the peak inverse current? Peak inverse current is nothing but I max sin omega t. Now for this, what is happening? We have two currents I1 and I2 which are flowing into the diode. In case of I1, I max sin omega t, what is happening? The another period which is from pi to 2 pi, we have nothing as the output. Similarly, in I2, I am sin omega t, what is happening? From 0 to pi, we are getting 0 at the output. So, if we are joining these I1 and I2, we will get the whole waveform, which is nothing but I max sin omega t, which is working in positive as well as negative half, but shifted into the positive one. So, we are getting the output in 0 to pi as well as pi to 2 pi. So, the peak inverse current is nothing but I max sin omega t, with the condition that from 0 to pi I1 is working and from pi to 2 pi I2 is working. Okay. Now we will discuss the third term here, IRMS. IRMS is our root mean square current, which is nothing but the AC component present in the current plus DC component present in the current divided by 2, because we are considering the mean here. So here in full wave rectification, we have two currents, I1 and I2. So if they both are equal, we can consider at I square, or similarly they are I max square. Why so? Because the I max is the I max is the current which we are getting at the output. So these are I max square divided by 2. We know that IRMS is root mean square. So we have to consider the root of this whole equation. So we are considering I max square by 2. If this is in under root, we will remove the sign of a square here. So finally we will get our IRMS is nothing but under root of, sorry, if we remove the root here, it will be nothing but I max divided by under root 2, because this is root 2 and if I am considering here, so we will consider root 2. So this is the value of IRMS. Now we will consider our, so IDC is our DC output current, which is nothing but 1 upon pi, because we are considering the cycle 0 to pi. The limit will be 0 to pi and I sin omega t dt. We know that I is here I max. So further we will calculate, and here 1 upon pi 0 to pi, I is nothing but I max sin omega t dt. Now we will put the values over here. So I max pi minus cos pi minus cos 0. We will consider minus like this. So cos pi is nothing but minus 1. So here I max by pi, cos pi is minus 1, and similarly cos 0 is plus 1. So this is nothing but minus 2 over here, and if we multiply it with minus which is in outside the bracket, it will become plus 2. So this is 2 become I max by pi, and this whole term will become positive of 2. So we have the value of IDC now. So IDC is twice of I max by pi. This is the current value of DC output current. Now we will consider our form factor. So form factor is our RMS value divided by the average value. So we know that IRMS and IDC, we both have the value of IRMS and IDC. IDCs are this and IRMS we have this, I max by root 2. So we are putting these two value I max by root 2 and 2 I max by pi in form factor, and we will calculate Kf as pi by 2 root 2. And if I put the value of pi and divide it by 2 root 2, it will become 1.11. So Kf for full wave rectifier is 1.11, which is little less than half wave rectifier. So the efficiency of full wave rectifier is more than half wave rectifier. Now we will consider our last term, which is nothing but ripple factor. So ripple factor is the ratio of AC component present in the current over the DC component present in the current. Now we will further calculate. We know that IAC or AC component plus IDC, which is DC component present in a particular current, is nothing but root mean square current or IRMS. From here we can see that IAC is nothing but IRMS minus IDC. We know that IRMS is root mean square current, so we have to put a under root here for the final value, and if it is under root we have to put a square inside the under root. So this is the IRMS square minus IDC square, which is the final value of IAC here. Now we will put the value of IAC in our ripple factor formula. So this is our ripple factor formula. IAC is nothing but under root of IRMS square minus IDC square divided by IDC. If we further simplify it, we are getting IRMS square with sign of under root divided by IDC, and here IDC square with under root divided by IDC. So in final, what we will get ripple factor is equal to, now what will be the ripple factor now? It will be, if we are considering under root in both sides, so it will be IRMS over IDC whole square. And this is nothing but this will cancel out because this is IDC and it is square, it is square root of I square DC, so they both are IDC and IDC, so they will be cancel out. So this is the R ripple factor finally. Now we know that the ratio of IRMS over IDC is nothing but the form factor, which is KF. So this is nothing but under root KF square minus 1. So this is our ripple factor formula. Now the value of KF we already calculated is nothing but 1.1 in case of full wave rectifier. So it will be 1.11 whole square minus 1. If we further simplify it, we have the value 0.48 at the output, which is nothing but ripple factor for full wave rectifier. If we talk about the ripple factor of half wave rectifier, which we done earlier, is nearly 1.55, or in some books it is written 1.57. But in half wave rectifier, we know we just calculated the ripple factor, which is less than 1, and it is 0.48. So it is very less in case of half wave rectification. It means the efficiency is more in full wave rectification. Efficiency of half wave rectification is nearly 80% and efficiency of full wave rectification is 40%. We can clearly see that the ripple factor is nearly 0.48, whereas in case of half wave rectification, in case of half wave, the ripple factor is 1.57 or 1.55. So here we can see that marvelous change in the ripple factor is there. So due to this application, we prefer full wave rectification over half wave rectification. Why so? Because at output we will get high power, and due to the ripple factor, which is very less in case of full wave rectification, the output which we called as the efficiency also is very high in case of full wave rectification, which is nearly 40, and in half wave rectification it is nearly 80. In some books, the exact value of these will be written somewhere. It is range from 40 to 45 and 80 to 85. So, considering the middle term, I am considering here 40% to 80%. It means just double the half wave rectification. We will get the efficiency just double the half wave rectification in case of full wave rectifiers. Now, this is the whole discussion of center tape full wave rectification process. In next class, we will do bridge rectifiers. Thank you so much.